All right, let me this. All right. I guess before class gets started, I just want to check in with you guys. How are you guys doing? How's the homework coming along? Good. Who's done with the homework? All right. Okay. Great. Okay. And who is still struggling greatly with the homework? Okay. All right. Well, I've got office hours after class, so you know the deadline is approaching fast, but you know. Come by and we'll see what you can do, and we'll see how we can help. So today's topic of the day is functions, and let's talk about this. Okay. This is an important concept, right? So you guys already had to write some functions as far as your homework goes, okay? And so today I just want to deal a little bit more with kind of some function ideas. Your next homework assignment, which I'm still writing the instructions for, I'll get that up probably tonight. That's just how it goes, right? You turn one thing in and I give you something new to do. Your next assignment is going to involve you writing a lot of functions, okay? I don't know about a lot, but a handful of functions that you've got to think through, okay? So today's lecture will talk about kind of the way functions work, and then also we'll talk about just some strategies for writing a function, okay? All right, so here we go. This is how we define a function. I think you guys already know this, right? You give it the name, all right, and then you say into this name, into this object name, we're going to call function, and then you give it the names of the arguments that you're going to use. You give it the expressions that you're going to compute, and then it returns some kind of output object, right? In general, the expressions that you run go inside these curly braces, okay? But if your function only has one line, you technically don't need the curly braces. Style guidelines say always use the curly braces, okay? But if it's only one line, R will understand what you're trying to do, okay? So here, we are, a function will return anything inside return, or if it will return the last line of code, all right? So in this case, there's only one line of code. The last line of code is x times x, so this function will return the value x times x, okay? A function itself is an object, so you can throw it into lists, you can do stuff with it like you can do with other objects. So if you throw a function to a list, the list will look like this. It'll say it contains a function, right? If you ask what is the type of, R will say it's a closure, okay? All right, you can explicitly return a value by using return, all right? And so, so one thing to keep in mind is that the purpose of a function, okay, from R's perspective, is that a function only exists to take in and out input or something and return a value. Once it returns a value, the purpose of the function is complete, okay? And so, so if you're writing code and you include a return statement, okay, as soon as the code executes that return statement, it will be done, and then and anything after that return statement will not get executed, okay? It's return basically will kill the function, okay? It's running, it hits return, it returns it, and then the function is gone. It's done, okay? So, so the recommended style is actually not to use the return statement and just let the function return the very last value that it calculates or executes, okay? But you do use return statements, okay? Like I think in my isPrime function, I have return statements, and that's if that's for like earlier on, right? So basically, if it turns out to be 2, just return true, okay? I think that's like the special case for the is prime function and stuff. So that's what we have, okay? So you can use a return early on so that it exits early before executing anything else. Otherwise, the recommended style is just let R return the last line that was executed. Okay. An important thing is that functions can return only one object, all right? So if you want to get multiple objects back, multiple values back, you've got to combine them. You've got to combine them together into either a vector or into a list. So here, we're going to return the values x, x squared, and x cubed, and I've combined them all into a vector here, all right? So I plug in f of 2, it gives back 2, 4, and 8. No surprise there, right? Here I've combined the values I want into a list, a named list. X is x, square is x squared, cube is x to the third, and we run that and it returns a named list, $x, $squared, $cube, okay? And this is how we handle multiple values. And this is going to be a common situation where you need multiple values, your function to return multiple values, and probably the most common way to do this is to use a list, okay? Unless it's a simple thing where you can kind of combine everything into a vector. But with lists, you can embed other lists, right? So, for example, like in 101A, you create linear models and stuff, right? And then when you do LM, what does LM return? It returns a huge list, right? A huge list of class LM where there's like the call and the residuals and the this and that and all of this stuff. There's a whole bunch of stuff, the coefficients, and there's actually, I think, lists of lists in there and stuff. So it's a big list, okay? And that's how R handles the values that a function returns. Okay, when you define your function, you are also defining the names that you use in the arguments, okay? The argument names. And then when we call the function, we use these argument names to provide values for it, right? So if you don't specify the argument names, R assumes you're putting them in the order that they appear. So here's a very simple function. It takes x, y, and z. It takes 3 arguments in, and then it turns them all into strings, and it pastes them together into one big string. Okay, so I have x equals x, y equals y, z equals z. So if I plug in 1, 2, 3, it gets x equals 1, y is 2, and z is 3. If you explicitly use the names in the call, you can put them in any order you want. You can say z is 1, x is 2, and y is 3, and then the function runs, and it says x is 2, y is 3, z is 1. Okay, because this is what the function reports, right? If you only give it the names of like 1 or 2 arguments, R does its best to try to match up the values with the arguments and spits it out. So I've got y is 2, and then I give it 1 and 3. So it plugs y into 2, and then it puts 1 into x and 3 into z, right? And here I've got something similar, y is 2, 1, x is 3, and it tries to match these up, okay? And then here I give it an argument, m equals 1, and R says, I don't know what to do with this. Unused argument m equals 1, okay? Because I've given it an argument that's not part of the function. Argument values are required. So if you've defined a function, any value that's used inside the function needs to have a value. Any argument inside that inside the function that gets used. So here, I've taken the same thing, but in my function definition, I've actually defined another argument w. But the function actually doesn't use w. It only uses x, it uses y, and it uses z, but it doesn't actually use w. And so when I call the function and I give w as 4, R is like, okay, it doesn't complain that there's an unused argument, okay? It says, well, w is part of the definition of the function, so that's fine. And then it runs, okay? Here I give it functions 1, 2, 3, okay? Or arguments 1, 2, and 3 for x, y, and z. I don't actually give it a value for w, okay? But it still runs because W is not part of any of the expressions that are run inside of the function. Okay. Again, here's the same function before. This time, I give W a value, but I didn't provide Z. So now R gives me an error. Okay. It says, you're trying to do this command here, paste all of these things, and it requires a Z, and argument Z is missing. So I can't do this. Okay. So that's so R gives us an error. So to avoid situations like that, we often recommend that in situations where it makes sense to provide default values. Okay, you want to provide a default value for x, y, and z. You do that with the equal sign when you define the function. You have function x is 1, y is 1, z is 1, so on and so forth. Okay, and so now I can call the function without providing any arguments, and it uses all the defaults. Okay, if I provide it one argument, it will go into the first argument, so x becomes 2. All right, or you can give it names and say z is 3, and it plugs in the defaults for everything else. Okay, so that is functions and arguments, and I don't think there's any huge surprises here. This is an important concept. Values created inside a function only exist inside the function. We will talk about this a lot more heavily on Friday when we talk about scopes and environment. Okay, but this is a key idea that when you run a function, the values that you create inside the function, you assign things like within the function, you're assigning values and stuff. The values inside the function exist only inside the function. Okay, and the only way you can get a value out of the function is by making sure that value is on the returned object. Okay, so the function's doing its thing, and if you don't put the thing you're calculating and stuff into the returned object, it just poof disappears when the function's done running. Okay. In general, you should never try to use a function to change values in the global environment either. Okay, so in today's thing, we're not going to talk about this. On Friday, we'll see an example, but functions don't change values in the global environment. That's just something you should just think of, okay? So here, 10 is defined in the, x is defined in the global environment, and it takes on the value 10. So 10 is assigned to x in the global environment. I create a function f, okay? F takes x, adds 55 to it, saves it back to x, and then the function returns this new value of x, okay? So I run f of x. X is 10 in the global environment, so it's f of 10. It returns 65, okay? But when I ask what is the value of x is still 10 in the global environment. This assignment of doing x plus 55 onto x doesn't change anything in the global environment, okay? The x that exists inside the function is like a totally different x, okay? It's a totally different thing. It's created, and it has nothing. This x and this x have no connection, okay? Other than they have the same name. All right. So again, just to kind of reiterate this, all right. If you want to store the output of a function, you need to assign that value somewhere, okay? So here x is 10. We run f of x. We get 65. If I ask what is x, it's still 10. If I want to store this value 65, I need to assign it somewhere. Here I can say take the result of f of x and store it back to x. Now x is 65. I imagine you've encountered this issue in like 101A when you're running LM, okay? There's probably a time where you said LM and y tilde x this and this and this, data this and that, okay? And you forgot to assign the output of LM somewhere, right? So you run LM and it outputs like coefficient this and that, okay? But you can't actually work with it unless you said LM and then you assign the output of LM to say like model 1 or something like that, right? And if you don't store the output of the function, whatever the function calculated is just lost forever. So you need to store the output somewhere. And so So this is what we do, okay? The function returns a value. That value that gets returned gets stored somewhere, okay? And so this is, one of the key differences between print and cat. Cat does not return values, okay? Cat just outputs stuff to the screen. Print outputs stuff to the screen, but it also returns a value, okay? So you can capture that value from print. You can't capture any values from cat. This is my guideline. This is not like a rule, but I think it's a good rule. It's a good rule to follow, okay? I want you guys to be thinking about writing functions, okay? If there's a task during your coding, if you find yourself copying and, like, if there's a task, sometimes you say, well, oh, I need to do this again, but this time for a different variable, okay? Maybe one of the first things you do is you just say, okay, I'm going to copy this chunk of code, and I'm going to paste it and change the variable names, okay? That's a very natural thing to do, okay? You copy some code that you wrote, you paste it down here, you change a couple variable names, and it does what you want to do in this other situation. That's a normal thing to do, okay? If you copy and paste, if you do this thing twice, you should start thinking about a function, okay? And if you find yourself, you're about to copy and then paste it a third time, then you definitely want to create a function, okay? At that point, when you find yourself copying and pasting it and doing the same thing a third time, make a function out of it, okay? Because later on, let's say you find out, oh, you want to make a small tweak to the calculation or the thing that you're doing, okay? If you've copied and pasted it a bunch of times, you've got to make that change everywhere. And it's going to be annoying and opens you up for making a mistake, because if you did it 6 times and you changed it in 5 locations but not the 6th one or whatever, okay, that result's going to be different, right? If you write a function, then you only have to change it 1 time in the function, and every call to that function will now have the updated code, okay? It could be as simple as, during some analysis, maybe you need to make a plot, the same kind of plot for several different variables, okay? Or the same kind of plot for several different models, okay? And it could be something like, oh, you know what, I want to make a residual plot, but let's change the color of the residuals that are more than 3 standard deviations away, or something like that, right? So, you say, all right, plot residuals, blah, 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 color the points, blah, 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 this and that, okay? And then you say, okay, well, let's do it for model 1, let's do it for model 2, let's do it for model 3, let's do it for model 4. And you're copying and pasting the code every single time, okay? What you want to do is write a function, okay? Because later on someone says, oh, you know what? I think the plot will look better if we use red for 3 standard deviations away, and then let's also do blue for 4 standard deviations away, okay? Now you have to like redo all of the stuff and all the locations for every single model you created. It's annoying, okay? If you just create a function and just say the input object is, model, and then for this thing we're going to create the residual plot, and then leave variables, it's much better, okay? All right, so just some overall advice. When you name your function, it should be clear what the function does, okay? I look at students' code and I see like function F, function G, function H, function whatever, okay? It's convenient to write function names that way, but we have no idea what F does, F, G, or H. These are not descriptive names, okay? So give it a better name for what it's doing, okay? If the function returns true or false, probably the name of the function should start with is, okay? So like, for example, is prime will return true or false based on whether the number is prime or not, okay? If you're checking for some kind of condition and it's going to return true or false, name your function is something, okay? The functionality should be simple. This is a subjective thing, right? I guess simple and quickly understood for you, right? So everybody has different degrees of ability to read and write code. So you want to keep, when you write a function, you want to keep it simple enough that you understand what it's doing, okay? You can have a lot of lines of code, but it should be simple enough where you can say, this is what it's doing, okay? And again, the overarching principle is that it's better to change code in one location as an inside the function rather than to change code everywhere because you copied and pasted the same commands everywhere. Okay, so I want to talk about some strategies for writing a function, okay? I know you guys had to write functions for your homework, all right? But for your next homework, you're going to have to write more functions, and I think using some of these strategies will, I think, will be helpful, okay? So, for example, our example is going to write a function to execute the bubble sort algorithm, okay? Are you guys familiar with bubble sort? Yeah, okay. Maybe yes. So some are nodding yes, some are nodding no. Okay, it's just some code, an algorithm that will sort a vector. Okay, so how do you sort a vector? It's not an efficient algorithm, but it's simple to explain. Okay, and so this is straight from Wikipedia. It says starting from the beginning of a list, compare every adjacent pair, swap their positions if they're not in the right order. Okay, that is the latter one is smaller than the former one. Okay, and after each iteration, one fewer element or one less element is needed to be compared until there are no more elements left to be compared, okay? So here is a vector, 51824, and this is how the bubble sort algorithm works, okay? We start off with 51824. We look at the first two values, 5 and 1, and we go, are these in order? These are not in order because 5 is bigger than 1. So we swap the two. So this becomes 15824. Then we look at 15824, and we look at 5 and 8. We say, are 5 and 8 in order? Yep, they're in order. We don't do a swap. Then we look at the next adjacent pair, 8 and 2. Are those in order? Nope, 8 is bigger than 2, so we swap them, and we get 15284. And then lastly, we compare 8 and 4, and we say, are those in order? They are not. Okay, so we get 15248. And at the end of this first sweep, we know, because we've always kind of compared two values at a time, we can be confident that the very largest value is all the way to the right. Okay, so we know that 8 is in the correct position. So in the next iteration, okay, we can lock 8 in. Okay, we know that the largest value is in the correct position, and so when we do swaps, 8 is locked in, and so we do the same thing. We say, are 1 and 5 in the correct order? They are, so no swap happens. And we ask, are 5 and 2 in the correct order? They are not, so we swap 2 and 5, okay? Then we ask, so now we are at 1, 2, 5, 4, 8, and then we ask, is 5 and 4 in the correct order? They are not, and so we swap them, and we get 1, 2, 4, 5, 8, okay? And at the end of this iteration, we now know 5 is in the correct location. We can lock that in. 5 and 8 are locked in. And so 5 and 8 are locked in. They're in italics here. Okay, and so I have 1, 2, 4, and 8, 4, 5, 8. Okay, this is actually already in order, but the algorithm doesn't know this, so it's going to keep doing these checks. Okay, so it's going to say, okay, 1 and 2, are those in the correct order? They are. There's no swap. Are 2 and 4 in the correct order? They are. There's no swap, and it locks those locks the 4 into position. Okay, and then we do one last sweep. It asks, are 1 and 2 in the correct order? They are. So now we know 2, 4, 5, and 8 are in the correct positions, or in other words, the entire vector is now in the correct order. So 1, 2, 4, 5, 8. And so this is how bubble sort works. Is that all right? I don't know if anybody, this is the first time you've seen bubble sort, if that feels confusing. Okay, here's a animated GIF. Okay, it takes a little while, but it looks at 6 and 5. Are they in the correct order? They are not. It swaps them. It moves to the next pair. Are 6 and 3 in the correct order? They are not. So it swaps them. Are 6 and 1 in the correct order? They are not. So it swaps them. Okay? And then it looks at 6 and 8. Are 6 and 8 in the correct order? Yes. No swap happens. 8 and 7 in the correct order? They are not. So we swap these two. And then are 8 and 2 in the correct order? They are not. So we swap them. And then finally, are 8 and 4 in the correct order? They are not, so we swap them. And after we swap this, we know 8 is in the correct position. It's locked in, right? And then we repeat the whole thing. We ask 5 and 3. So I know it takes a while, okay? So we swap 5 and 3. 5 and 1 are not in the correct order, so we're going to swap these, okay? Then we look at 5 and 6. Those are in the correct order, so no swap happens. 6 and 7 are in the correct order, so no swap happens. 7 and 2 are not in the correct order, so we swap those. And then 7 and 4 are not in the correct order, so we swap those. Okay. And the process continues, okay? So, so we swap 1 and 3, and so on and so forth, okay? All right, so we don't have to watch this whole thing. All right, is that okay for bubble sort? So we're gonna code this up. So what does this look like when we code it up, right? So guiding principle, anything big, a big task, a big job can always be broken down into smaller jobs, okay? And this is for all of life, right? You've got some big goal to accomplish, break it down into smaller things, right? I don't know, there's some motivational quote talking about trying to build a castle or something. Starts with laying one stone. It's true, right? The journey of 1,000,000 miles starts with one step or something. I don't know. Nobody starts a journey of 1,000,000 miles. But we're going to break down bubble sort into some very, very, very small tasks, okay? So one part is we're going to say, let's compare two adjacent values and swap them if they're not in order, okay? And that can be further broken down into comparing adjacent values, like with an if statement, and then swapping two adjacent values, okay? So this is going to be kind of our first thing that we're going to code. And then what we're going to then do is perform multiple sweeps on the vector. Each time we perform a sweep, we do one fewer comparison here. All right, so here's another key piece of advice. When you start writing code, don't immediately start writing a function, okay? Because again, when you run a function, it creates its own separate environment. All the values inside the function exist there, and as soon as the function is done, all of those values go poof and they're gone, right? And so if your function is not operating the way you want, at the end of the function, all the values that would have given you clues as to what went wrong are gone, they are lost, okay? So my recommendation is don't write a function and don't create a function, just work directly in the global environment, okay? Get your code to work in the global environment, and if something's not behaving the way you want it to behave, you can investigate and look at the current values of everything and say, oh, it's doing the wrong thing here, and that will give you a clue on how to fix it. So here's just an example of me doing the wrong thing where I say, I just want to swap the first two values of the vector, right? This is a very reasonable goal, all right? And again, we want to break things down. So this is like a good step, but I'm going straight into writing a function, okay? And so I say, all right, let's take the second value of x, put it in the first value of x. And let's take the first value of x and put it in the second value of x. And let's have the function return x, okay? So I say, all right, x is going to be the vector 5, 4, 3, 2, 1. And then what happens when I run the code on x? I get 4, 4, 3, 2, 1. Okay, and I say, that is not what I want. I want to see 4, 5, 3, 2, 1, right? I want to see the 5 and the 4 swap, so it becomes 4, 5, 3, 2, 1. But again, because all of the code happens inside the function, I can't really see what happened. So instead, we're going to stage the code inside the global environment, okay? And so when you do this, you want to always make sure you clear out the global environment every single time, so you're not dealing with old values from the last time you tried something out, okay? So here I'm going to start off by just deleting everything. rm is list equals ls. That deletes everything from the global environment. I create my vector x. X is 5, 4, 3, 2, 1. And then I try this. Okay, let's see what happens. We're going to take the second value of x, plug it into the first value of x, okay? So 5, 4, 3, 2, 1 becomes 4, 4, 3, 2, 1, okay? We want 4 to go in the first position, and we want 5 to go in the second position, okay? But now when I do x, take the first value of x and plug it into the second position of x, we see, oh, you know what? I lost that value 5. The value 5 is nowhere to be found. It got written over by 5, okay? So this gives me a clue on how to fix the problem. I have to do something about saving that value 5 before I overwrite it with the 4, okay? So here, so I just wipe everything out again, all right? I create my vector, x is 5, 4, 3, 2, 1. And now, the first thing I'm going to do is I'm going to take the first value, store it into temp. Then I take the second value of x and put it into the first position. And then I take that temporary value and put it into the second position, okay? And so now when I check, yeah, this worked. Okay, now we got 4, 5, 3, 2, 1. Indeed, we have successfully swapped the first two values, okay? And again, I'm able to figure out what went wrong because I'm working in the global environment and I can check kind of the intermediate steps. All right, and then so anytime you get something to work, don't just say, all right, I got it working and let's keep going, okay? Always just test to make sure it works with other cases, right? And so this is what distinguishes an okay programmer from a good one, is that a good programmer is able to think of more test cases so that, especially edge cases, where the code might not behave the way we want it to expect, and can anticipate these things and plan for them in their code, okay? So here, anyway, we just write x is 1 through 8, and let's try the same code. X goes to, the first goes to the temps, put the second into the first, put the temp back in here, and when we check, yeah, 1, 2, 3, 4, 5, 6, 7, 8 is now 2, 1. We swap the first two values, and then 3, 4, 5, 6, 7, 8, okay? So the swapping works, but now what we want is we want to have a condition check to say only do the swap if they're in the wrong order. Only do the swap if they're in the wrong order, right? So what do? I'm going to take this code and I'm going to put it inside an if statement. I'm going to say if they're in the wrong order, do the swap, and otherwise don't do anything, right? So I took the exact same code and I just put it in the if statement. If x1 is greater than x2, do the swap, okay? So here I test this out. I'm going to try x is 5, 4, 3, 2, 1, and I run the code, and yeah, it swapped. 5, 4 was in the wrong order, and now it's in the correct order. 4, 5, 3, 2, 1. Okay, let's try it this way. 1, 2, 3, 4, 5, I should do no swap. I run the exact same code, okay? I've just changed my test case, run the exact same code, and indeed there's no swap. It remains 1, 2, 3, 4, 5. So this is a good sign, okay? All right, so this is how we broke it down, and we got something like, for this part, kind of works, okay? It only works for their first two values, but what we want to do is we want to perform a sweep for the entire kind of vector of values, right? So what we can do is we can put this in a for loop, right? So rather than just doing the first two, we can do the first two, then the next two, then the next two, and the next two, right? So that's what we're going to do, okay? So all I have to do is, this is what I've written, swap the first two, swap position 1, swap position 2. I'm going to make a for loop, okay? And I'm going to replace the 1s with I and the 2s with I plus 1. Okay, so I'm going to basically say for I in 1 through 5, okay, so sequence length of x is basically 1 through 5, okay, the length of x is 5 and sequence length 5 is 1, 2, 3, 4, 5. So I'm going to say for I in 1 through 5, basically do this exact swapping thing. So I do the swap code, and I just replace the 1 with I replace the 2 with I plus 1, and I put that inside the for loop. I do for I in sequence length x, which is basically for I in 1 through 5, 1 colon 5, you can kind of think of it that way, do the swap, right? If xi is greater than xi plus 1, then do the swap, and so on and so forth. Okay. So I run this code, and what happens? I get an error message. Okay, what went wrong? Okay, so again, here's a situation, right? I'm working inside the global environment, so now I am able to check the value of everything in my global environment, okay? If I put this in a function and I get this error message, all of the values that I was working with existed in the function and now they're gone, okay? So by working in the global environment, getting your code working in the global environment first, okay? Or if you run into trouble, you can kind of figure this out. Okay, does anyone know what's going on here? Why am I getting this error message? The error message says missing value where true false needed. Yeah.
Because you're doing if xi is greater than xi plus 1, when it gets to sequence length 5, then you're doing x of 6.
Right. Okay. So again, the error message, right? So another part of being a good programmer is you can understand these error messages, right? So what we do is we look at this error message and it says the error message is in this statement. If xi is greater than xi plus 1, this is where we're encountering the error message. And we're getting a missing value with true, false, needed. So let's just look at the values that appear in the statement. Let's look up I. I is 5. Xi is 5. Xi plus 1 is x of 6. And that's a missing value. And we go, oh, okay, that makes sense. I can't compare this value to a missing value. I'm going to get a missing value And we know that if statements can't handle missing values, right? So what's the solution? The solution is, when I got to the end, I'm trying to perform a comparison that I don't need to compare. So really, even though my vector is length 5, I really need to do 4 comparisons. 1, 2, 2, 3, 3, 4, and 4, 5, okay? And that's only 4 comparisons. So all I do is I just make a small modification. I just say for I in sequence length, length of x minus 1, okay? And so this is trying to illustrate like how to think about your code and build incrementally, right? If you try to do everything all at once, you're gonna have a bunch of errors and you're not gonna know what goes on, right? You go incrementally, you figure out what's causing each problem along the way and you fix it, right? So here, I got for I in sequence length, length of x minus 1, okay? And I run this, okay, on the vector 5, 4, 3, 2, 1, and indeed, it moved the value 5 all the way to the right. Okay, and that's what I want. Okay, this was the first sweep. The first sweep just takes the largest value, pushes it all the way to the right. Okay, again, anytime you get something working, run another test case to make sure it is actually working. So here I just create another test case, 1, 2, 5, 8, 3, 6. What we want to see when I run through this exact same code is that the largest value gets pushed all the way to the right. Okay, here's another case. I just take 10 values, I put them in random order. I run it, and indeed, value 10 gets pushed to the right. Okay, so this seems to be working. Okay, so now the rest of bubble sort is, so we've got the first sweep down, and so the rest of bubble sort is, let's just perform this sweep multiple times now. Okay, each time, so the first time I get the rightmost value, the next time I get the second rightmost value. So I'm going to just take this entire code and I'm going to put it inside another for loop, okay? So I've got a double nested for loop. This is not recommended in R, but it's fine, okay? This is the bubble sort algorithm, and it's not the most efficient thing. This is just what we're doing. So all we're going to do is we're going to just follow the same thing, okay? One more position is going to be locked, perform multiple sweeps. So I just take the code and I just put it inside another for loop, okay? So here, just kind of using the same idea, I just say for S in sequence length minus 1. So I'm going to just say, all right, if I've got a vector of length 5, do a sweep and do 4 of these sweeps, okay? And technically it works, okay? It sorts from 5, 4, 3, 2, 1, it sorts it correctly into 1, 2, 3, 4, 5, okay? So that's fine, but we're not really doing the true bubble sort algorithm, which says some of these positions get locked in and we don't have to compare the entire vector, because at this point what I'm doing is basically it gets to here, it does the swap, it gets to 6, 4, it does the swap, and then technically the code as I have it currently written is that it's going to compare 6 and 7 again, and it's going to compare 7 and 8 again, okay, which will slow down our operations. Not by a ton, but it's a little bit unnecessary.